In this last video, I'm just going to talk about box plots. I'm going to try and keep it short. So, first of all, this is a box plot. Well, actually, these are two box plots. And technically, it's a box and whisker plot. So, it should be labeled as box and whisker plots. And these are the whiskers. This is the box. And there's two different ones here drawn on top of each other. Now, first of all, when you draw a box plot, this is kind of like what you need to draw the box plot. In order to draw the box plot, you need to know 5 pieces of information. You need to know the smallest value, or the minimum value. You need to know the lower quartile. Actually, let me do it in a different coloured pen. So you need to know the minimum value, the lower quartile, I'm just going to abbreviate it to LQ, the median, the upper quartile, and then the largest value, or maximum. Now, when you draw a box plot, you need to know these 5 pieces of information, and this is where they go. So on a number line, you draw whiskers at the minimum and the maximum value. So this is the minimum, this is the maximum. Your box then starts at the lower quartile. So this line here is where the box starts. That's always at the lower quartile. And then the box ends at the upper quartile. So this is the upper quartile. And then the line in the middle is where the median is, because that's the middle. So this is the median. And that's how you draw a box plot. Why are they useful? So this is why they're useful. Here is 2 box plots drawn above each other. Really, one box plot on its own isn't very good, but 2 or 3 together are very good because you can compare one against the other if you draw them on the same kind of scale. So, what was I going to say? Yes, so here, for example, is 2 box plots, and they represent an exam. The top one is a non-calculator test, and the bottom one is a calculator maths test. And let's just say it's like a mock exam or something like that. You can see kind of like the distribution on these box plots. You can see that the diagram for the non-calculator test is very compact, and then the one for the calculator test is more spread out. So one thing you compare is where the medians lie. So here's the median for the non-calculator test, and here's the median for the calculator test. And you can see that on the calculator test they did slightly better. So you can say on average they performed better. Perform better on the calc test because the median's slightly higher. Okay, and the next thing you want to look at is the interquartile range, so which is a measure of consistency. And the interquartile range is the distance between the upper and lower quartile, literally the length of the box. So if you look at the box, you can see that this box has got like a bigger interquartile range. That's the interquartile range. Remember, the interquartile range is the upper take away the lower, but that's literally just the length of this box here. And you can see that this box has got a kind of a bigger interquartile range, and this one's got a lower interquartile range. So you could say that the non-calculator test, they were more consistent on that. So the non-calc test, they were more consistent because the interquartile range is smaller. Now, why is the interquartile range better than working out the range, for example? The range, remember, is the highest take away the lowest, or the maximum take away the minimum. The highest take away the lowest is the range. But why is the interquartile range better? Well, let's say, for example, someone did really, really well on their test and they were way, way over here, for example, like way over there. So the whisker went all the way up to there. Well, the range would be massive then, wouldn't it? It would be the distance between the maximum and the minimum. So this person, like, it might just be one person that got a really good score on the test, and they might be kind of like way over there in the distance, but the range would be massively affected by it. But the interquartile range doesn't get affected by really big results, or on the flip side, really low results. So if someone got a really small result, like way over there, then like it kind of affects the range, but the interquartile range is not affected by it because the box would kind of stay where it is. It's not really affected by where the whiskers are. So the interquartile range is better because it's not affected by something called outliers. Outliers are kind of like freak results that kind of don't tend to happen, like results that end up being way over there that makes the whiskers really big, but the interquartile range kind of stays where it is. It's sort of like, it looks at the interquartile range looks at the heart of the data. That box is the heart of the data. It's kind of like where the middle 50% of the population is. It's right in the middle. This is kind of like the middle 50%. So anyone who kind of like is like got a really good result, a really bad result, it doesn't really affect that middle spread. They kind of stay where they are. Now, what was the other thing I was going to say? Okay, one thing to note about box plots is because it's based on quartiles, each section of the box plot represents 25% of your population. So that means 25% are between the minimum and the lower quartile. So 25% of the population are there. 25% of the population are between the lower quartile and the median. So 25% of the population is there. And then so on. So each one of these sections, oops, let me do it in a different color. Each one of these sections represents 25% of the population. So 25% of the population finished in this bit. And the last bit, so 25% of the population are in this section here. So for example, let's the upper quartile on the x-axis, what number is that? Okay, that number is, okay, that's 11, 12, that's 13, so that looks like 12.5. Okay, so that means the upper quartile is 12.5. That means 75% of the population were below 12.5 or less than or equal to 12.5 in this kind of like test. And 25% of the population are above or equal to 12.5. These inequalities don't really matter too much whether they're equal to or not, but so if you look at kind of like the region, 75% of the population are below the upper quartile and 25% of the population are above it. So it's a really good indication of like the spread of the data. And the IQR, the really good thing about the IQR is that it just measures the spread of that middle section. It just looks at that middle section and sees kind of like where the spread are. So anyone that gets like a really high result or a really low result doesn't affect that middle spread. That kind of stays consistent. Okay, so that's kind of like box plots. Typically speaking, cumulative frequency curves and box plots are connected. They're kind of like drawn kind of like one after each other. So when you kind of like have your median, you go across and you go down, and then you have your lower quartile, which was somewhere, where was it? It was about here, wasn't it? Across and then down, and then you have your kind of like your upper quartile, which is sort of like across and then down. And then what you do is you kind of draw your box underneath that, because this is where your median would be. This is where your upper quartile would be. This is your lower quartile, so this would be your box. And then your whisker would kind of go up to the maximum value, which is 185. And then the lowest possible value is 155. So this would be your box plot. And typically speaking, they're kind of connected together. So I hope that clarifies kind of like what box plots are useful for. They're kind of like a good... One box plot on its own isn't very good, but two kind of together, you can see kind of like the spread of the data. You can see where chunks of the population are in terms of like test results or heights or weights or anything like that. And the good thing about the IQR is that any kind of like extreme results doesn't really affect that middle 50%. They kind of like stay where they are. So you can just look at the heart of the data or the heart of the population, that middle 50%. Okay, I hope that clarifies things. And that's kind of like the last video on this. And then what you need to do now is do the My Maths task, and maybe if you want to do a bit more caboodle stuff. And that's it for now. Thank you for watching these 3 videos. I know they've been a bit long, but they kind of needed to be. Thank you very much, guys.